Today, we're going to jump into Unit 7, which is solving right triangles. We're going to dip our toes into trigonometry as we go on, but first we need to understand how to work with squares and square roots. And when we say something is squared, we are raising it to the second power. So the exponent is 2, which means you are multiplying the thing by itself twice. So 3 squared is 3 times 3, which is 9. 5 squared, 25. 7 squared, 49. And you should honestly, by now, know. You need to memorize these. Your squares. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared, here we go, is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. You should be able to confidently know at least through 13, preferably through 15, all right? Because you need to be comfortable with this. So we have our squares. 3 squared is 9. There we go. So what is the square root? The square root is the something times the something. So the square root of 9 is 3. Square root of 25 is 5. The square root of 49 is 7. See our connection here? 7 squared is 49. So the square root, which is what times what makes 49, is 7. Squares and square roots are the opposites. So a perfect square is the product of a rational number, basically any integer and itself, all right? Rational number. And there's our perfect squares list. Look, it's down there too. The symbol square root means you've got to find the square root of the number. So what two numbers are that are the same, multiply together to get that number. So the square root of 9 is 3. The square root of a perfect square, folks, this is basically a memorizing thing. All right? You should know this by now. The square root of 64 is 8. There you go. It's right here, and it's in my little list I wrote over here. Now we can use a calculator to approximate a square root. If you put the square root of 64 into your calculator, you're going to get an answer of 8 or 8.0, depending on how your calculator is set up. Well, if we're going to find the square root of 21, let's think first. Is 21 a perfect square? Well, you go back to the previous page and no, 21 is not a perfect square. It is the product of 3 and 7, but those are different numbers. So 21 is not a perfect square. So you type it in. Some calculators, you do square root, then the number. Other calculators, you do the number and then the square root. It just depends on which one you're using. Okay, so if we say round your answer to the nearest hundredth, you underline the place value you're rounding, which is the second one. That's 100th. And then you look at the digit after that. So the final answer from the square root of 21 is 4.58 because 2 does not round up. Now, I want you to try, pause this, and approximate the square root of 76. And I'm going to do it too. So what I got was 8.7177978887. Now I'm going to round it to the nearest tenth. So I want to round to this one. So I look at the next one, and that's a 1, and a 1 does not round up, so my answer is 8.7. That is an approximate answer. Okay, with me so far? Now let's simplify the square root of a number less than 100. I'm throwing you back into middle school, maybe elementary school, doing a factor tree. All right? A factor tree is a very simple way to find any perfect squares that are factors. So, what times what is 54? 9 times 6. And what I do with my factor tree when I'm finding factors of a square root, I continue putting the square root symbol over my factors. That helps keep me straight. Now, is either of these a perfect square? Yes. So I found the largest perfect square of 54 and rewrite it. So it's the square root of 9 times the square root of 6. So there's my work. I do my work in the wrong place. Square root of 54 equals the square root of 9 times 6, which also can be shown as the square root of 9 times the square root of 6. Now I'm going to take the square root of the perfect square, and that is the square root of 9. The square root of 9 is 3. So what I end up with, see this? I end up with 3 times the square root of 6 equals the square root of 54. First, you find the largest perfect square factor of your number. In this case, it was 9. Then you take the square root of the perfect square and write that number on the outside. Remember how when you learned algebra, you learned that 3x meant 3 times x. We didn't write a multiplication symbol. It's the same concept here. We don't write 3 times the square root of 6. We write 3 right next to the square root of 6. That means multiplication. It means 3 times the square root of 6. So 3 times the square root of 6 equals 54. Now we're going to try simplifying the square root of 45. Excuse me. I like my factor trees. What can I say? All right. I go to whatever I can find that is simple. 5 times 9. The square root of 5 times 9. So let's put them together. Is 5 a perfect square? No, it's not. Is 9 a perfect square? Ooh, it is. This becomes 3. So the square root of 45 is 3 times the square root of 5. We'll do some practicing at the end. Now you're going to simplify the square root of a whole number greater than 100. Same concept, except it's going to be a couple more steps. I'm going to change colors on this. Now my general rule of thumb is I want to factor out perfect squares. So when I look at 176, I don't want to factor by 2 because 2 is not a perfect square. I want to factor by 4 or by 9 or by 25, things like that. I'm going to factor by 4. Square root of 4, and that goes in. I'm going to use my handy dandy calculator because I just don't want to make a mistake. 4 times 44. Now, 4 is already a perfect square, so I'm not going to mess with that, but I can break down 44. Square root of 4 times the square root of 11. Alrighty. Now, remember what I did up for square root of 45. I have perfect squares, right? Square root of 4 is 2. The square root of 4 is 2. So what I have is 2 times 2 times the square root of 11. So 4 times the square root of 11 is 176. And you know how to check that? To check that, and I'll put that in a different color. To check, you take your outside number, square it, and then multiply it by what's under the square root. 16 times 11 equals 176. There's your check. Alrighty, now we're going to rationalize a denominator. Now, why do we say rationalize? It's because a square root is not rational unless it is a perfect number. If you put the square root of 3 into your calculator, it goes on forever. The square root of 5, the square root of 7. But if you put the square root of 9 in your calculator, you get an integer. So the square root of 5 and the square root of 7 are irrational numbers. So when we rationalize the denominator, we're taking the irrational square root of the denominator and we're doing math to make it a rational number, an integer. You cannot leave a square root in the denominator. So what we need to do is rewrite the fraction without a square root. And naturally, we have to do it with math. Can't just rewrite it. So you multiply the numerator and the denominator by whatever the square root is in the denominator. So let's look at this. The square root of 7 times the square root of 7 is the square root of 49, which is 7. And 7 is a rational number. Now we're going to multiply this. When you multiply a square root times a square root, you can just multiply them together and keep them under the square root bar. So let's look. 5 times 7 is 35. So this is the square root of 35. 7 times 7 is 49. And we know the square root of 49 is 7. So our final answer is the square root of 35 over 7. I know 35 and 7 have common factors, but you cannot take something out from under the square root symbol, the radical sign. We cannot do that. So we leave it as the square root of 35, or sometimes we say radical 35, over 7. So you've learned, we're throwing in a bunch of rules here. When you multiply symbols under the square root sign, you just multiply them and keep them under the square root. Okay, moving on. Now we're going to rationalize this one. Rationalize this denominator and simplify. And simplify means if you can take out any common factors, take out any common factors. Okay, if you look at this, radical 11 or the square root of 11 is in the denominator. So you multiply the entire thing by the square root of 11, which becomes the square root of 3 times the square root of 11 over the square root of 11 times the square root of 11. You end up with the square root of 33 over 11. You cannot simplify this. There are no perfect squares in 33. We know that because in our previous step we saw square root of 3, square root of 11. Neither of those is a perfect square. So this is our final answer. Now we're going to show it to you, and it looks weird, but it's not. You can rewrite this as square root of 2 over square root of 7. It is the same thing. Okay? Now remember, I'm throwing so much at you. Let's play around for a little bit. Square root of 2 times square root of 7 equals square root of 2 times 7. You can multiply them together. I'm just showing you this. So if I can multiply them together and put them under the same radical, I can divide them and put them under the same radical. That's why I wanted to show that to you. All right, let's rewrite it. Now that we've taken, we have rewritten this square root of a fraction, which looked so freaky and complicated. Oh, now it's easy. You know what to do. Multiply by the denominator. Square root of 14 over 7. There you go. Square root of 14 over 7. You cannot reduce that because the 14 is under the square root symbol. You cannot reduce that fraction. Okay, and there is my answer. Now multiply a non-radical by a square root. Okay, really heavy, complicated stuff. 10 square root of 2. Whew, wow, wipe the brow. Isn't that great? You need a little bit of easy stuff in this. All right, now we're going to do a quotient involving square roots. I need to rationalize this. Do I do anything differently? I do not. I still multiply the numerator and the denominator by the square root of 7. I get 2 radical 7 over 7. Can I reduce this? No, 2 and 7 do not have any common factors. So this isn't so bad, is it? Rationalize this denominator and simplify. Let's take a look. Multiply everything by the square root of 6. I have 11 times the square root of 6 over 6. 11 and 6 have no common factors. I cannot make it any simpler. It is simplified. Now on this last page, it is straight practice, but I'm going to go ahead and do them. If you want to stop the recording now and just do the work on your own, go for it. All right, this is a memorizing. Square root of 100 is 10. The square root of 16, well, that's 4. Those are on the chart on the first page, and you should know these by now. All right, the square root of 22.4, well, goodness gracious, I'm going to do that in a calculator. Square root of 22.4. And I'm going to give you a little note here. I didn't give it to you. Round to nearest hundredth. I think I spelled that right. All right, so here my answer is 4.73286, and I want to go to the nearest hundredth, so I'm going to get 4.73 is my answer. All right, square root of 57. It's another calculator exercise. It is 7.54983. I want to go here. I end up with 7.55. Now, square root of 32. I'm going to factor this because I know 4 times 8 is 32. 4, 8. Oh, and I know 4 times 2 is 8. So I end up with, let me break it up for you. Square root of 4 times 4 times 2. Well, what's the square root of 4? 2. Square root of 4 is 2. My final answer is 4 times the square root of 2. A lot of steps, but I wanted to do it that way. I wanted to show you. All right, let's do 75. Now, again, I think squares. 3 times 25. Okay, this, well, that is simply 5 times the square root of 3. Alrighty. Now 245, that's a big one. Well, let's see. I'm going to start by, let's see. I'm going to see if maybe a square works. That doesn't work. Well, what is 245 divided by 25? That doesn't work either. So let's keep on going. Let's think. We know it's not going to be 1, 9. Let's go. Let's multiply. Let's divide by 5. When in doubt, do the simples. 245 divided by 5 is 49. Hey, we have a square. What's the square root of 49? It's 7. So the square root of 245 is 7 times the square root of 5. All right, the square root of 250. That's 25 times 10. 10 is not a perfect square, and there are no perfect squares that factor into it. So the square root of 250 is 5 times the square root of 10. I know you're sometimes going to have issues with the fact that, wait a minute, 10 can be factored down. It doesn't matter. You're looking for perfect squares. Yes, 10 can be factored by 2 and 5, but 2 is not a perfect square, and 5 is not a perfect square. So you cannot take them out, and that just is really tough for us to get. Square my answers. Haha. All right, I'm going to work on this one, rationalizing. Multiply top and bottom by radical 2. 2 radical 2 over 2. Now this is an interesting one because it's 2 times radical 2 over 2. 2 and 2 have common factors. I can divide these by 2 and I end up with radical 2 over 1. The reason I can divide these is this is 2 times radical 2. It is not 2 plus. It is 2 times. I can factor out when I'm multiplying. Should have learned this a long time ago in middle school. All right, number 10. Rationalizing. I get square root of 15 over 5. Cannot do anything else with that. That's it. That's all I got. Okay, I'm going to rewrite the square root of 10 over 3 as the square root of 10 over the square root of 3. Multiply both parts by the square root of 3. Square root of 30 over 3. Are there any perfect squares in 30? There are not. You cannot divide by 4 or 9 or 25, and that's all. Alrighty. Now, a couple different ways you can do number 12. Is there an easier way to write 3 over 6? There sure is. 1 over 2. Okay. Now, this becomes square root of 1 over the square root of 2. Multiply both sides, top and bottom, by the square root of 2, and you end up with square root of 2 over 2. And that is your final answer. That was a fun one. All right, went through a lot of material, kind of quick. The more practice you do, the better it goes. Do you know why I didn't factor? In fact, do you know why I didn't do anything special with the square root of 57? Well, let me show you. If I divide this by 3, my answer is 19. And 3 and 19 they're actually prime numbers. They are not perfect squares. So this doesn't get me anywhere. I knew I didn't have a perfect square in there. All right, lots of material. Do your practice.